Good morning, students. So, topic of today's discussion is controlled strategies. We learned that we have got production rules. The next question that arises is in which order we are going to apply the production rules. Apparently, the order in which the uh, rules are applied is control strategy. It describes the order of application of the rules to the current state. And what is the use of this control strategy? The use of this is that uh, there is a movement from one step to another step, or from one state to another state, from one state to another state to move. Here, a rule has to be applied, or if you consider a status space search method, operator has to be applied. If you apply rule or operator, the system would move from one state to another state. And it is very necessary because you want to reach the solution. If it is not properly done, then what happens is there would either be a loop, start state, um, next next state, next state, and here we can get again start state. So it would be in loop, would not derive a solution, or next state and next state. Suppose this next state is invalid state, uh, even that will not take to the solution. There are two directions in which search could proceed. What are the two directions in which search can proceed? The first direction is data driven search, called forward chaining. This is under this control strategy. We find that the two directions are data driven search, also known as forward chaining. Now, will you tell me what do you mean by this forward chaining?
The sequence will be the execution will be in a sequence, ma'am. The way it is
Yeah, sequence means
from like ascending or descending order from top to bottom, like the way we define.
hmm, from top to bottom is right in the way that you start from start state through number of intermediate states, you reach the goal state. This is forward chaining or data driven. The next method is goal driven search, also known as backward chaining. Will you tell me what is backward chaining?
Here we need to specify, ma'am,
What
which goes, or otherwise it will take the required statement depending on the query.
is
I
it
think
possible
from
to?
goal state to that previous state, ma'am, initial state.
Yes, exactly. Very good. Here we start at the goal state and
Ma'am, one
through
doubt.
number of, yes,
Ma'am,
yeah,
how can
please go ahead.
how can system will know that that is the goal until and unless it performs any action?
We have to specify to system. Here we specified that this is the start state and this one is the goal state. Then
Okay.
the system knows that I have to begin from here and eventually reach here. If you
So it
reverse it,
reverse engineering like that. So it will come from back.
exactly, reverse engineering, reverse engineering. You specify goal state and you say that start from with goal and eventually reaches to start state and list out the um, you know, steps or states to reach to the.
Start state.
It is like that. Yeah, it is like that.
Okay, ma'am.
Next subtopic is characteristics of a problem. What is a problem? Can anyone define me what is a problem?
It's a user query.
Right,
Any
right. Any other definition?
means it can be anything which related to mathematical or any other field. Like example, a small search for any items that can be also a problem. Or any
Yes,
findings we want to discover, that is also a problem. So it
yes,
can be anything.
yes. Uh, yes. Anyone else would like to add up to this?
Yes, ma'am. Anything, as Shawan said, anything that is that appear to be in proper, but that needs to be like projected in proper way. So that can be treated as problem, and we need to have multiple solutions to get it corrected.
You are also right. The problem is a situation or a state uh, which has to be investigated or demonstrated based on some kind of fact or law or rule and solve it to arrive to a solution which is said to solve that problem, solve that state and take out the people or the system from that state into the next state which is desirable. That is as the solution. Do you think that there are different properties Basically, here, as per the suggested book, the problem types mentioned are of three. First type of problem is ignorable. Second type of problem is recoverable, and third one is irrecoverable. Ignorable problems are those whose solution steps can be ignored. The example is when you are proving a theorem. In order to prove a theorem, you need to use some of the lemmas, and while you take up one lemma to prove a theorem, you realize that this lemma is not useful to prove a theorem. What you can do is you can just ignore this lemma and continue with the next step to reach the solution. This is ignorable. In order to prove the theorem to reach to a particular conclusion, intermediate steps includes uh, i- going for a lemma, and if it is proved later to be not that useful, we can ignore that step. This step can be ignored, and another lemma can be taken up in order to prove the theorem. That is ignorable. Recoverable, here we can after finding a solution, if the steps can be undone. Undone means undo. If you can undo a particular step, it is recoverable. Irrecoverable problem are those problems whose solution steps cannot be undone, uh, can't undo a solution step. Example, when we tried solving water jet problem, we tried applying a particular rule, and we feel that this rule is not leading to the solution. What you can do is you can undo in the sense that instead of uh, that rule, you can go for another rule, and you can um, take the system to next step by going through another rule, not that one which you chose earlier. That is, you are undoing. And here, fill a uh, if you fill water jug with water, there is a rule to empty the water as well. Therefore, uh, if you fill it, you can remove it. But then irrecoverable kind of problems do not allow such undoing process. Take for example chess game. In chess game, if you have to move a if you have to take your you know if it is your turn, you have and you have chosen a step, you cannot undo. You have to fix it to that.
Pawns should cannot be undone.
which, yeah, it cannot be undone. That whatever you have taken, no, your next move, it cannot be undone. That is irrecoverable. And these are the types, characteristics involve decomposability of a problem.
So, ma'am,
Hmm.
yesterday we saw that puzzle also we cannot be undone, right, ma'am? We need to go through the steps. We need to move that empty slides, though that is not the. We need to move each and every number, right, ma'am, to
Wait,
obtain the state. Will it be a irrecoverable problem?
which one? Name of the problem, please
Puzzle,
tell me.
puzzle, eight puzzle problem.
Eight puzzle problem. Yeah, that is also not recoverable. Once you move the blank block to up, left, or right, then it means
We,
you have taken a move.
yes, ma'am.
Yes, that is also irrecoverable. You're right. Decomposability of a problem is one of the characteristic. What do you mean by decomposing?
Breaking the problem.
Yeah, breaking the problem. Uh, Dividing the problem into small steps such that solving the each step and then combining those steps to find the solution. That is decomposability of a problem. Some problems can be decomposed, whereas others might not be decomposed. Role of knowledge. What is the role of knowledge in solving a problem?
Understanding the problem's query the user need. That is it now?
Yes, it is. If you don't understand what is your problem, what are the rules, and how you are trying to find a solution without the knowledge of rules and facts and that entire problem, it cannot be solved. Therefore, knowledge plays a vital role in the solution of a problem. Consistency of knowledge base. What is this implies? What is knowledge base? Knowledge base is the um, collection of rules and facts. For instance, in missionaries and cannibals problem, we have rules in which we state that we said that mm, cannibals should never outnumber missionaries, otherwise it leads to killing of the missionaries. That is the primary condition in that problem. And if there is no consistency maintained in the rules, what did we do? We came up with the rules such that you can have two missionaries, zero cannibals, one missionary, one cannibal, or um, there was no rule in which you had uh, two missionaries and one cannibal at one side. No, sorry, it is one missionary and two cannibal. We did not come to that stage where we had one missionary, two cannibal at any other, at any side of the river bank or in the boat. So what does it implies that it is the set of rules are consistent. It says the same thing throughout. If it is deviating from what has been put the condition, what the restrictions are, then it is not consistent. Then it is inconsistent. And inconsistent rules or knowledge base will not lead to the correct solution. there is another characteristic that the solution requirement of solution can be an absolute solution or relative solution. Absolute solution are those solutions that have got exact answer. Absolute means exact. And relative solutions are those that are approximate. Will you give me any example for exact solution and approximate solution?
Pi value is approximate, ma'am.
Which one?
Pi value, if we
Pi
use it,
value?
it will give approximate like 3.14. It won't
Hmm,
give
hmm, hmm,
like decimals, as Jagdish said.
hmm, hmm.
And absolute are normal integers, if we can say.
Hmm. Yes, you are right. In the context of the problems which we have covered, which problem is exact and which one is approximate?
The cannibals one is exact, ma'am,
Right.
because we have multiple ways to go, but solution is only one. We should move all three cannibals and missionaries to this side, so it will be exact.
Hmm.
In
Hmm. You are right,
in
Shravan. The yeah, Jagdish, you are also right. Water jug is also exact.
water
The
jug and puzzle also it is exact, ma'am, because we
yes,
defined the
yes, you are right. But then can you make a guess which problem would be approximate or a relative?
what was it?
Have you heard about traveling salesman problem?
Yes, ma'am.
That is not
Cost it.
yeah, that is not a absolute
Mm.
solution problem.
But ma'am, one doubt. Sorry for
Uh,
interrupting.
no.
Uh, but in
Good.
that cost will be defined, no, ma'am. We find the very shortest path, right? Depending on the graph, it will become absolute. If we do any modifications, then it may relative or tentative solution we'll find for it. But according to the requirement, we'll find absolute solution, no, ma'am. In type
Yeah,
TSP.
yeah, as per requirements, we can find that. But then in traveling salesman problem, when you're when the person is traveling across the cities, how many paths would be there
That's
for
what, ma'am. It
for a
depends on the.
computer system? For a computer system um to implement it would take years and years. A traveling salesman problem. What we are doing is we are approximating it. We are giving some
Mm.
time complexity and then so a few parts out of yeah, we have that is unlimited actually. Instead of unlimited, we are going for some limited parts, and we are specifying the rules and then coming up with a solution which is working well, which can be implemented. But then if you don't go with all those conditions, if you want to exhaustive search means Now we will understand what is exhaustive search. In exhaustive search, there are several problems. We have NP problems. Uh, those NP problems are the problems which cannot be solved in a deterministic time. They are non-deterministic time algorithms. Okay.
Okay, madam.
So let us begin a new topic. With this, we have done with uh, problem solving, general problem solving topic. In that, you had production system, water jug problem, missionaries and cannibal problem, state space search. Today we looked at control strategies, characteristics of problem. Let's begin another topic, which is exhaustive search. Exhaustive search is also known as brute force or uninformed or unguided search. To discuss exhaustive search in detail, we should have basic information about what a search is and how many kinds are there. A search is performed in order to find a solution. It's like searching for a solution. There are two kinds of searches: uh, exhaustive search and informed search. Exhaustive or uninformed research. Okay, let us call it as uninformed research and informed research. In uninformed research, system will explore all the options that would spawn from the present state. Whatever is the state the system is in, from that state, what are the options available? All the options are explored further. All sub options of those newly generated options are searched, and the process continues. This type of search is known as uninformed search because there is no guidance provided, or there is no uh, hints given. It is up to the system to perform exhaustive search. That's why it is exhaustive, in the sense all options it has to look for and find out the one which is leading to the goal state. That is uninformed search. Informed search, some kind of clues or hints or suggestions or heuristics are provided to the system, such that system would make use of those in order to quickly find a solution. And it apparently eliminates the exploration of all the mm, states that would arise from a present state. Therefore, this is not known as it is non-exhaustive search. Whereas this first one is exhaustive, second one is non-exhaustive. First one is known as uninformed, the second one is known as informed. First one is known as unguided, second one is known as guided.
Hello, ma'am.
Yes?
Could you repeat the informed once, please?
Yeah, okay. Now with example, I will tell you. Shravan, suppose you have gone to a unknown city, a city which you are not aware of. Okay, first time you have entered that city from the railway station. Okay, you entered at railway station or airport or some place. Railway station. After reaching the railway station, it's like you have to reach to a particular hotel. Okay, you have booked a place and you are nowadays GPS is there and all that is the secondary thing. But consider that there is no GPS at all. Consider the days when there was no GPS and there was no idea about the places. From that point to reach to your hotel, you have no fixed solution actually. There is no fixed path. You ask a person, their taxi person or auto person, if you ask, they say that that hotel is very far and we have to take this route and that route. Because you may not know, you just take it and he will take you through a long route and uh, leave you at the destination. Okay, you can have a short route, you can have a long route. Because you are new, you have no idea, you are totally uninformed about that place, and there is no guide, no one knows about that, your friends or family. So that is unguided. uh, or exhaustive means if you don't believe that person, you have to look for so many different options available, and you choose anyone perhaps. In other type of searching, which is informed, to reach to a hotel, although you are in unknown city, you may ask your one of your friends and he knows it. He gives you some suggestions. You first take this route, and from there you go to that next subsequent route. Then after that you reach to that place, from that place you do like that. That is informed search. uh, you describe the same thing to that taxi person over there, and what he what impression he would get, he would essentially feel that you know the area, although you may not know, but you have got some idea because that place have been described to you earlier by someone who knows it. So through short and long route, you might go through short route because of the guidance given to you by your friend, that is informed. This way it is totally uninformed. You probably taking the long route. Is it
Okay.
clear, Shravan?
Yes, ma'am. Ma'am,
Hmm.
we were following state space search, right? In this recent problems, what we have done, that can also be a inform. It comes under informed or uninformed, ma'am, because we are exploring all the options in that also, but we are skipping that which are not valid. Will it be considered as informed or uninformed?
um, it is what is your problem you're talking about?
Any problem, ma'am. I'm talking about that methodology, the state space search. In that
Okay, then it
search,
is uninformed. Through that is uninformed. Consider missionaries and cannibals problem. In missionary and cannibal problem, we started here. It's there. We started with the state space search we used. Even okay, consider this problem here. Uh, the start state is leading to the next three states, and here all the possible options are being explored. And if it is not leading to a solution, it is being discontinued. That the search from that point is not proceeded.
yes, ma'am.
It is stopped, and every option is being tried upon no, here. So it is uninformed or exhaustive search.
Okay,
Consider that you, yeah, exhaustive. Yes, Jagdish, it is exhaustive.
okay, ma'am.
Consider that we are not opening up to these states only. We know that because some guidance is given, some information you have in advance about the problem that you would face if you arrive at this site. You may not expand this at all. You may expand only this side. It is
Okay,
totally uninformed or exhaustive. We are looking for all the options, and even here we are looking for all the options. This is also exhaustive search. Here,
yes,
there are three options. You have explored all the three. Here you found two. You went uh, ahead with the two. Here there are four options. You are going with the four options. So this is exhaustive,
got it, ma'am.
uninformed. The searching mechanisms that are belonging to this category of exhaustive search. Brute force, have you heard about brute force, the term brute force? Brute force also means exploring all the options available. First one is breadth first search. Second, let us list out all, then we will discuss each of them. Depth first search. Depth first iterative deepening. Third one, depth first iterative. Next, fourth one is bidirectional search. All right, these four methods come under uninformed search techniques. Moving on to the first category, first type, which is breadth first search. This is known as DFS. This one is known as DFS. This is DFID. This one is BDS. first method, BFS, breadth first search. This is a searching strategy that expands all the states one step, at a time. Or we can say expand all states level wise or layer wise. Initially, it expands all the states one step away from the start state, followed by expansion of all the states two steps from the start state, subsequently three steps away from the start state, and so on until goal state is reached. Or in short, it can be said as expansion of states level wise. These are levels. This is level number 0 or 1. If you begin at 1, this is level number 1, 2, 3. Or you can say that it is depth wise um, in expansion of states at the same depth. Or it is like breadth wise expansion. This is a breadth. This level is expanded. Next level is considered for expansion. Further, next level, and so on until goal is reached. Is this clear, students?
Yes, ma'am. It will explore all the options in that layer, then goes to another layer.
Yes, exactly. That is the point. Whatever options are available in a particular layer, that is considered to be explored. Later, the next layer is uh, explored. That is the breadth first search mechanism. When this is applied to a water jet problem, what is the start state of a water jet problem? Start state is both the jugs have 0 gallon of water. On the application of rules, we have come up with two states, one step away from the initial state or start state. This is start state. When you have expanded the start state, you have arrived to two substates. This is rule number 1. This is rule number 3. From here, what you have to do? You have to find the substates with respect to 5 comma 0. 5 comma 0 is what? It is the present state in which 5 gallon jug has 5 gallon water and 3 gallon jug has 0 gallon water. Here, 5 5 gallon jug has 0 gallon water and 3 gallon jug has 3 gallon water. You expand this state in which it is 5 comma 0. After expanding Here you get 0 comma 0, which is again uh, a start state, which therefore cannot be further explored and has to be stopped. Exploration should not continue from that point. There is another state, uh, and the third one is this 2 comma 3. All the substates for this particular state has been expanded. All right. uh, Actually this I should not write here x. We are at this level only now. Here also we get 5 comma 3, 0 comma 0, 3 comma 0. This is 1, 4, 5. This layer is done. This is layer number 1, 2. Layer number 2 is done. Now we are at level number 3. At this 3, we should consider expanding each one of them. How many are there? There are 6. This cannot be expanded because it will not lead to uh, any state as it is in looping state. 5 comma 3 would give, on the application of rule 2 comma 4, and from this side on the application of 1 comma 2, you are not leading to anywhere. So that also cannot be explored further. Whereas on the application of rule number 4, 2 comma 0 is arrived. State 2 comma 0 is arrived. This is expanding at this level. Number 3, this left side is done. Can you do this right side expansion? Will you tell me how we can move ahead? Yeah, students? Yes, students. Can anyone tell me, you understand? Are you getting that or not?
Ma'am, once go back.
Once again,
No, ma'am. Once you go back to the slide, ma'am.
go back.
Slide.
Hmm.
Here, this 5 and 3 are representing jets, no, ma'am. In 0 comma 3, or the amount of water it is filled in this in the
Amount of
jet.
water filled in those jugs. First jug is 5 gallon or 5 liter. The second one is 3 liter. So here these two denote the jugs, but then the value in of those two entities are the amount of water.
Okay. 0.3. Here only we gave 1, 4, and 5 states. 2 and 3 were missing. Already we have taken. That's why we are not taking, ma'am. Here 5, comma 3 we have taken. 0, comma
5,3 state.
we are totally filled those
Here
extra.
is 5,3 state. It's both are filled up. No, when both are filled up, it will it take us to our resolution?
No, ma'am.
Both are filled up. Here both are filled up, so here nothing can be done. This we have to stop exploring from this.
Hmm.
Here 0, comma 0 again should be stopped. It is a loop again. We have to go again, start state, begin from there. Even if it's not loop, it's like unnecessary expansion. No? If you put this start state here, further you have to go with 5, comma 0, 0, comma 3. It will be ambiguous. Ambiguity would it would lead to ambiguity. Here, what can be done? It is 3, comma 0.
Yeah, it can be moved to next state where
It
4,
can
comma
move to
0
next
will.
state. Yeah. What state it can move to?
It can be 4, comma 0. If but here I'm not understanding how we can add this. We are randomly giving some number, ma'am, here, or we are following a process to add something.
We are applying the rule. Here we have applied the rule when both are having 0, 0 water. We can fill 5 gallon jug with 5 gallon water, 5, comma 0, which is rule number 1. Okay, production rules. We learned production rules, no? Is it in this notebook or it's not here? Maybe in another one, problem and solution.
If that is the case, we can directly take here in next state 4, comma 0, ma'am, because that will be also an option in next state.
What is the option?
4, comma 0, because we are moving to next state now, ma'am.
Mm-hmm. These are the rules. Shravan, rule number 1 is to fill 5 gallon jug. So
Yes,
5,
ma'am.
comma y. Y is all is 0, so there you get 0. Rule number
Yes.
3 is whatever is 5 value, you are filling 3 gallon jug. So x comma 3.
5, comma
Now you
3.
tell me, now you tell me what. 3 comma 0. When you have 3 comma 0, what rules you can apply on it? 3 comma 0, you can
We can add in
we
X.
can we can even apply rule number 1. How you can apply rule number 1? You can fill this 5 gallon check.
Yes,
So
ma'am.
it would be 5 comma 0. 5 comma 0 again, it's already here, so you don't expand it further.
Mm.
Actually, this should come in the next step. I'm putting here, it is
Here
not
we
there.
can take 4, comma 0, ma'am. If
4 comma 0.
because filling can be 1 liter or any 5 liters, no, ma'am. We can fill 1 liter in that, or we can fill 2 liters in that. So that will be also a possible solution.
But no, Shravan, there is no measuring mark.
Oh,
How
okay,
will you
okay,
say you are filling 1 liter or 2 liter? You can fill either 5 liter or 3 liter.
okay, ma'am. Got it.
We can't say 1 liter, 2 liter, 3 liter. 3 liter we can say for 3 liter jug, but you cannot say 3 liter for 5 liter jug.
Yeah, yes, ma'am. Got it.
So, students, today's task is we just complete this and try to also find the solution using DFS. DFS is depth first search, where you expand uh, this state by going through in one direction. That there may be multiple outcomes from here, out states. Multiple out states would come, but then you follow one path. From here you go to this path first. From here you go to this path first. If it cannot be explored further, you return. You go to the next one, that is depth first search. If possible, you try for that also. If not, complete this tree, and we will discuss this in our tomorrow's class.
Okay.
Students.